Hi and good afternoon to the summer course. This is Sunit Kumar, your mathematics teacher. So students, so Devi Maya will wait for 1 or 2 more minutes for others to join, and then we can start the lecture. So we'll just wait for a minute and then we can start. So hello and good afternoon, everyone. So welcome to Q&I summer course. I am Sunit Kumar, your mathematics teacher. So students, we were doing polynomials in the previous class, and we had done relationship between the zeros and the coefficient of the quadratic polynomial, right? So let us start the class and then we'll go ahead with the concept and do some questions also today. So let's start it, students. So, so as I said, we'll continue with the chapter polynomials today. And this is our third lecture. Prerequisite for today's class is that you should understand algebraic expressions. You should know the degree of a polynomial, and you should also know the types of polynomial as according to the degree of a polynomial. And you should know to find the value of a polynomial at the value of some variable. And you should know how to find zero of a polynomial and what is zero of a polynomial. Now the outline for today's class, students, we'll do a relationship between zeros and coefficients of a polynomial, and we'll also do questions based on finding zeros of a quadratic polynomial. So relationship between zeros and coefficient of a cubic polynomial, we'll start with this. So I'll just quickly recap what we had done in the earlier class. So for example, if we have a linear polynomial ax plus b equal to 0, then we know that 0 is 0 of the polynomial, or the solution is x is equal to minus b by a. So this is negative of the coefficient of, so negative of the constant term divided by coefficient of x. Now if we have a quadratic polynomial, for example ax square plus bx plus c equal to 0, the relationship which we have seen is the sum of the zeros, that is alpha plus beta is minus b by a, and the product of the zeros, that is alpha into beta, is equal to c by a. So minus b by a means negative of the coefficient of x by coefficient of x square, and c by a means constant term divided by coefficient of x square. So these are the two relations which we did in the previous class, which we had seen in the previous class. Okay. Now coming to relationship between zeros of a coefficient of a cubic polynomial. So since the degree is 3 here, we see that we have also seen that in a polynomial, the degree of a polynomial, if it is equal to n, then the maximum number of zeros which the polynomial can have is equal to n. So because in a cubic polynomial, the degree of the polynomial is equal to 3, right? So in a cubic polynomial, since the degree is 3, so there will be a maximum of 3 zeros. Let's say these 3 zeros are alpha, beta, and gamma. So we have 3 zeros of this polynomial ax cube plus bx square plus cx plus d, right? Now the relationship between zeros and coefficient of a cubic polynomial is the sum of the zeros, that is alpha plus beta plus gamma, is equal to minus b over a, that is equal to negative of coefficient of x square by coefficient of x cube. You can see the coefficient of x square is b and coefficient of x cube is a. So that is minus b by a, right? Now, if we take two zeros at a time, the product of that and the sum of that is going to give us alpha into beta plus beta into gamma plus gamma into alpha is equal to c over a, that is coefficient of x divided by coefficient of x cube. Clear? Now, the third, that is the third relation, which is that the product of the zeros alpha into beta into gamma, this will be equal to negative of d by a, that is negative of the constant term divided by coefficient of x cube. So these are the three relationships in terms of cubic polynomial, where the sum of the zeros, the product of the zeros, and the product taken two at a time, these are related to the coefficient as given in this slide. So what you can do is quickly note this down, right? So that we can start with practicing the question. Has everyone noted this down? Okay. So let's go ahead, students. If you have noted this down, we can proceed. So we have to verify 3 minus 1 by 3 are zeros of the cubic polynomial 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and the coefficient, right? So first we have to verify whether these are zeros or not. So when does a value become a zero of the polynomial? So if we replace that value of the variable in the polynomial, and if the value of the polynomial becomes equal to 0, then we say that that value of the variable is the zero of this polynomial, right? So since we have p of x equal to 3x cube minus 5x square minus 11x minus 3, right? And we have to check whether these are the zeros of the polynomial or not. So first of all, let us check for 3. So for at x is equal to 3, p of 3 is going to be 3 times 3 cube minus 5 times 3 square minus 11 times 3 minus of 3. So this will be equal to 3 cube is 27 into 3 is 81. 9 into 5 is 45, 33, and then 3, right? So this is 81. We have 5 plus 3, 8 plus 3, 11. And then 4 plus 3, 7, and 1, 8. 81 minus of 81, which is 0. Now since P of 3 is 0, right? Since Can you see this now? Everyone, can you see my screen? Students, are you able to see the screen on which I am writing?
Yes, sir.
Okay. So since P of 3 is equal to 0, this implies that x is equal to 3 is the zero of the polynomial. Correct? Now we will have to check it for minus 1 and minus 1 by 3 as well. Quickly check it for minus 1. So if we check it for minus 1, p of minus 1 will be 3 times minus 1 cube minus 5 times minus 1 square minus 11 times minus 1 minus of 3. So this is minus of 3 minus of 5 plus of 11 minus of 3. So this is negative 11 plus 11, which is 0, right? So again, x is equal to minus 1 is a zero of the polynomial. Once you have done it for 3 minus 1, you will have to check it for minus 1 by 3 as well. So if you check it for minus 1 by 3, p of minus 1 by 3 is going to be equal to, put the value 3 times minus 1 by 3 whole cube minus 5 times minus 1 by 3 whole square minus 11 times minus 1 by 3 minus of 3. Correct? So this is 3 times negative of 1 by 27 minus 5 by 9 plus 11 by 3 and minus 3. So this is negative of 1 by 9 minus 5 by 9 plus 11 by 3 minus of 3. Is it clear? So if you take LCM here, so if you take LCM as 9, this is negative of 6, and then 11 times 3 is 33 minus of 27. So this is negative of 33 plus 33 over 9, which is equal to 0. Is it clear? Is it clear, students? So you can see that since P of 3 is also equal to 0, P of minus 1 is also equal to 0, and P of minus 1 by 3 is also equal to 0. So that means 3 minus 1 and minus 1 by 3 are all zeros. This has been verified. 3 minus 1 and minus 1 by 3, these are the three zeros of the polynomial 3x cube minus 5x square minus 11x minus 3. Is this clear? Have you understood the concept? Okay. So now we have to verify the relationship as well. So I'll rub this so that we can verify the relationship between the zeros and the coefficient of the polynomial. Yeah. So we know that now these are the three zeros. Alpha is equal to 3, beta is equal to minus 1, and gamma is equal to minus 1 by 3. These are the three zeros. Right? Good, Raghavi. Now the sum of the zeros is alpha plus beta plus gamma, which has to be equal to minus b by a, right? Let us check this. So this is LHS will be equal to 3 plus minus 1 plus minus 1 by 3. 3 minus 1 is 2 minus 1 by 3. 6 minus 1 is 5 over 3. Now the RHS is minus b by a. So minus of minus 5, because b is minus 5. Here we have a equal to 3, c equal to minus 11, and d is equal to minus 3. Okay. So now negative of negative 5 over a, which is 3, so which is again 5 by 3. So since LHS is equal to RHS, we say that this is verified, right? Now, if you see the second relation, that is alpha beta plus beta gamma plus gamma alpha is equal to C over A. So if you check this, alpha beta LHS is equal to 3 into minus 1 plus minus 1 into minus 1 by 3 plus of gamma alpha, that means minus 1 by 3 into 3. So this will become minus 3 plus 1 by 3 and minus 1. So this is minus 4 into 3 is minus 12 plus 1 over 3. That is negative of 11 by 3. And if you see the RHS here, student, the RHS is C over A. C is minus 11 over 3. So again, this LHS and RHS are equal. So we say that this is also verified. The second relationship is also verified. Clear? Is it clear, students? The verification of second relationship. Now we have the third relationship, which says that alpha into beta into gamma is equal to minus d by a. So let us verify that as well. So product of zeros alpha beta gamma, this is minus d by a, right? Now, as I said yesterday, so you will do first minus b by a, then you will move to right, and your signs will be alternate. So you will have plus c by a for the next one, and then minus d by a. So alpha beta gamma, the LHS is equal to 3 times minus 1 times minus 1 by 3, which is equal to plus of 1. And if you see the RHS is negative of negative 3 by 3, which is 3 over 3, that is again 1. So again LHS is equal to RHS. We say that this is verified. Is it clear? So what we have done, students, we have verified all the three relationships. First, we verified whether 3 minus 1 and minus 1 by 3, whether they are the zeros of this polynomial or not. And then we have verified all the three relationships. Is it clear? Students, is it clear? Devi Maya, Raghavi, Ragul, Alan, have you all understood this concept? Okay. Let's go to the next one now. So in this question, find the zeros of the quadratic polynomial. So you have to find the zeros of the quadratic polynomial. How do you find the zeros here? In this question, to find the zeros, what we do is we take 1 by 6 common here, right? Or what we'll do, let's say, first find the LCM here. So LCM here is 6. So we will have 6x square minus 11x, and then we multiply 2, so we'll have minus 10. So what we can do is we can write this as 1 by 6, 6x square minus 11x minus 10. So if we split the middle term, so 6 into minus 10 is minus 60. Okay. So to get minus 60, we have, we can do 10 times 6, we can do 12 times 5. Okay. So if you break this, 6x square minus 11x minus of 10, right? Now in this, if you break this, 6 into minus 10 is minus 60. How will you break the middle term here? You have to break 11 in two parts so that the product is 60. So if you break this into minus 15 and 4, so minus 15 plus 4 is minus 11, and the product minus 15 into 4 is minus of 60. So you will get 6x square minus 15x, right, plus of 4x minus 10. So this is 1 by 6. You can take 3x as common, you will have 2x minus 5. And then you can take 2 as common, you will have 2x minus 5. So this is 1 by 6. 3x plus 2 into 2x minus 5. Clear? So now this is equal to 1 by 6 times 3x plus 2 into 2x minus 5. So if we have to find the zeros, students, what we'll do? We'll equate it to 0. So when you equate it to 0, the 6 in the denominator will go to the other side, will become 0. So your x becomes 3x plus 2 is equal to 0. Or the other factor 2x minus 5 may be 0. If the product is 0, either of the factor is 0. So your x is minus 2 by 3, or x here is 5 by 2. Clear? Yes, correct. So these are the zeros of this quadratic polynomial. Is this clear to everyone? Students, are you able to understand this? Okay, let's go ahead. Have you all written this down? Now in this question, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. So what you have to do first, you have to split the middle term, factorize it, and then find the zeros of this polynomial. Once you have got the two zeros of the polynomial, you will have to verify the relationship for quadratic polynomial. That is alpha plus beta is minus b by a and alpha beta is equal to c by a. You have to verify this. Yes, correct, Raghavi. The zeros are minus 2 and 4. So let us split the middle term here. Minus 8, you can get it by minus 4 and 2 by splitting this minus 2 into minus 4 and 2. The sum minus 4 plus 2 is minus 2 and the product minus 4 into 2 is minus 8. So when you split this, you are going to get x square minus 4x plus 2x minus 8. So this here you can take x as common, you will have x minus 4. 2 as factor, you will have x minus 4. So you will have x plus 2 into x minus 4. These are the two factors. So if you have to find the zeros, you will equate it to 0. So x plus 2 into x minus 4 is 0. So this will give you x is equal to minus 2 or x is equal to 4. Now this is alpha. For example, alpha is minus 2 and beta is equal to 4. You have got the value of alpha and beta. Now you will put it in this relation and verify it. So alpha plus beta, your LHS, will be equal to minus 2 plus of 4, which is plus 2, and your RHS is minus b over a. So if you check it here, a is equal to 1, b is equal to minus 2, and c is equal to minus 8. So minus b over a, so negative of negative 2 over 1, which is equal to 2. So both LHS and RHS are equal. Is this clear? The first relation, is it clear? The verification? Okay. Now in next relation, that is alpha beta is c by a, your LHS is alpha into beta. So alpha is minus 2 into 4, which is minus 8. RHS is c over a, right? So c is minus 8 over 1, which is minus 2. Minus 8. Minus 8 over 1 is minus 8. So both your LHS and RHS are equal. So this second relation is also verified. Is it clear? Is this clear to everyone? Both the results verified. Quickly note this down. We can go to the next one now. Okay. Now in this question, you have to first find the zeros and then you have to verify the relationship between the zeros and the coefficient. So you have to tell me the zeros first. And you have to verify the relation alpha plus beta minus b by a and alpha times beta equal to c by a. What are the zeros? First, you need to tell me the zeros here. So if you equate it to 0 and do this middle term split, we have minus 4. So you will break it into minus 2 and minus 2. So minus 2 plus of minus 2 is minus 4 and the product is plus 4, which should be equal to the product of first and third term. So if you break this middle term, or if you split this middle term, 4s square minus of 2s minus 2s plus 1 is 0. Yes, Raghavi, zeros are 1 by 2 and 1 by 2. Now please verify these two relations. So now if you factorize this, we have 2s common, so you will have 2s minus 1. Minus of 1 common, we have 2s minus 1. This is 0. So this is 2s minus 1 into 2s minus 1 is 0. Or equate this, you will get s is equal to 1 by 2 or s is equal to 1 by 2. Right? So we have real and equal roots here. Now let us verify this relation. First relation, alpha plus beta minus b by a. So your LHS is alpha plus beta means 1 by 2 plus 1 by 2. These are the two zeros, which is equal to 1. And your RHS is C by A. Sorry, minus B by A. So minus B means minus of minus 4 by 4. That is 4 over 4. That is equal to 1. Clear? So this is verified. Now the next relation, alpha beta is equal to C by A. Our LHS will be 1 by 2 into 1 by 2. That is 1 by 4. And our RHS is going to be C by A. So C is 1 and A is 4. Again, this is verified. So you should also write here what A is equal to. So A is coefficient of S square, that is 4. B is coefficient of S, that is minus 4. And C is coefficient of C is the constant, which is equal to 1. So then you put these values of A, B and C in the relationship to verify the relationship whether it is correct or not. Is this clear, students? Everyone?
Clear, sir.
Okay. Let's go to the next now. Can you quickly tell me the zeros here and then we'll verify the relationships? You have to solve this and let me know the zeros here. So students, after we have done this class, we'll also practice on the platform now only just after the class. So once the class is over at 1:50, we will practice on platform till 2:20, half an hour practice session. So stay with us. Once the class is over, we'll log in on the platform and practice there. So you will have to rearrange this. So in the standard form is ax square plus bx plus c. This is your standard form of a polynomial. So 7x will bring it first. So 6x square minus 7x minus 3. Equate it to 0. Yes, Raghavi, the zeros are correct. Verify it now. So we know that we have to split minus 7 into two parts, so that 6 into minus 3 minus 18 is the product of the two parts as well. So if we split it into minus 9 and plus 2, minus 9 plus 2 will be minus 7, and the product minus 9 into plus 2 will give you minus 18. So we have 6x square minus 9x plus 2x minus 3 is 0. So you can take 3x as common. So we'll have 2x minus 3 plus 1, 2x minus 3 is 0. So we have 3x plus 1 into 2x minus 3 is 0. Right? So when we equate it to 0, you will get x is minus 1 by 3 or x is equal to 3 by 2. So these are the two zeros, minus 1 by 3 and 3 by 2. Now, once we have got these zeros, we will now verify the relation alpha plus beta minus b by a. So here you can check A is 6, the coefficient of x square. B is equal to minus 7, the coefficient of x. So this is your standard form. So we are taking it from here. And then C is equal to minus 3. So the LHS alpha plus beta, this is going to be equal to, what are the two zeros? Minus 1 by 3 and 3 by 2. So minus 1 by 3 plus 3 by 2. LCM is 6. So this is minus 2 plus 9. So this is 7 over 6. Okay. Next, your RHS is minus B by A. So minus of B means negative of negative 7 and A is 6. So which is again 7 by 6. So this is verified. Now students, alpha into beta is equal to C by A. Let us check this relation as well. Verify this relation as well. Your LHS is product of zeros, that is alpha into beta, right? So product of zeros, minus 1 by 3 into 3 by 2. 3 gets cancelled. So you have minus 1 by 2. Your RHS is C by A, which is negative of 3 by 6, which is negative of 1 by 2. So your LHS is equal to RHS again here, which is verified. So both the relations are verified with these zeros, minus 1 by 3 and 3 by 2. Is it clear, students? Are you able to understand?
Yes, sir. Understood.
Let's go to the next one now. You have to find the zeros of the given quadratic polynomial and verify the relationship here. So 4u square plus 8u. First step, you have to find the zeros. What are the zeros? What are the zeros, students? So when you equate it to 0, 4u can
Minus
be taken.
0, sir.
Can you repeat it?
Minus 2 and 0, sir.
Yes, correct. Correct, Ragul. So when you equate it to 0, so you have two factors, 4u and u plus 2. First factor will give you u is equal to 0. Second is going to give you u is equal to minus 2. So these are your zeros. Alpha is equal to 0 and beta is minus 2, right? And here you can say that a is 4, coefficient of u is 8, and your constant term is 0 because there is no constant term. Now the first relation, alpha plus beta equal to minus b by a. Your LHS is equal to alpha plus beta, 0 plus of minus 2, that is minus 2. RHS is minus b by a, so negative of 8 by 4, that is negative 2. This is verified. Alpha into beta is c by a. So this is 0 into minus 2 is equal to 0. This is your LHS. RHS is equal to c over a, that is 0 upon 4, which is equal to 0. Is this clear?
Yes, sir. Clear, sir.